This video is on Lesson 2 from the Grade 8 Module 2 book. So in this one, we are going to continue talking about translations today and three basic properties of them. Starting with exercise 1. So exercise 1 says, draw at least 3 different vectors and show what a translation of the plane along each vector looks like. Then we have to describe what happens to the following figures under each translation using appropriate vocabulary and notation as needed. Notation is going to be a big part of today's lesson. All right, so before we get into actually doing what the directions tell us to do, we need to kind of understand what some words mean. The first word being a vector. So a vector is a line segment with a direction. So not too complicated, it's just a line segment. But the direction part is important to realize because it tells you where the starting point is and the ending point is. For example, we might have, so a way to show this, if I said vector A, B, I would put the arrow above it, and the first letter shows the starting point. Starting point would be A, the second letter obviously, shows the ending point, which in this case would be B. So it's important to know which direction the vector is telling you to move, because in this case we're going to be performing translations based on vectors. So to get into the exercise they're talking about, it says draw at least 3 different vectors and show what a translation of the plane along each vector looks like. So with these images down here, first thing I would like you to do is mark up some key points of them. So we are going to use, for R, we're going to mark a point here, 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 and here. And then for R, let's mark this point A, B, C, and D. So we're going to move that shape R, it kind of looks like a quarter moon or a half moon shape. We're going to create a vector and we're going to move that half moon shape along the vector. So we're going to take a ruler. I'm going to leave my vector, let's see, I will put my vector, we'll put it like this. The angle is important, so the direction is important. Now from any given point, so we'll start with point A, and that kind of shows me I have to adjust. Again, this is just an example. In the future, you'll be given specific vectors to move it along. So I've decided for point A, I'm going to move A 25 dash marks to a different spot. So I'm going to mark right there as a point. My vector from here to there, there we have it. So I'm going to keep my ruler as is. Now we'll say this vector is vector U, W. So vector UW, and we're going to move A, we're going to translate it based on that. So from A to A prime. That symbol right there, when you have a 1, or it kind of looks like a 1, but it's actually an apostrophe. So A apostrophe, that's pronounced as A prime. That means it's point A after a transformation has been applied to it one time. So A prime. So when I translate one of the points along the shape, along the vector, I have to make sure I move the other points along the shape in the same way. So I'm going to grab my ruler again. So I moved A. Remember, that was 25 dashes on my virtual ruler. Let's go down to B. I'm keeping the same angle Therefore, I keep the same direction on my ruler. So there we have it. So B is right there, 25 dashes. There's 10, 20, 25 would be right about here. After I move it, it's labeled B prime. And I keep going with the other ones. C is right there. 10, 20, 25 is right about there. So there I have my point C prime. And one more, which would be D prime. D prime, there we are. 10, 20, 25 leaves us with D prime about right there. All right, and there we have it. So I'm going to use the technology I have to take a picture of this. There we have it. So after I took a picture of the same exact half moon image there, R, and I just moved it along my vector, I moved it so that A and A prime matched up, and we also see how B prime, D prime, and C prime also are in the same positions on the translated half moon, so the moon that was half moon that was moved, as they were on the original half moon shape. So when we translate an object, each point on the object, not just the 4 points I labeled, but every single point that eventually forms together to form these lines, also moves along that vector. If we look at a different one, we'll look at this Pac-Man image here. So the Pac-Man image over here, if I labeled this one A, B, and C, and we'll put another point over here for D. I have already translated the object, but the same holds true. If I look here, A, the vector A, the vector we use to move this shape, let's see, I'll draw the line. I notice how I had to go 10, 20, 29. I had to go 29 spaces on my ruler. Yours will be a little different because mine's virtual. It's relative to scale. So I had to move 29 spaces at a 10-degree angle to get to A prime. Now, as long as this translated correctly, B, C, and D should also have to move 29 spaces at a 10-degree angle. So sure enough, let's see, there's B, 10, 20, 29. So this is right where B prime should be. C, 10, 20, 25, 29. And D. D is right there. There we have it. 10, 20. Now 29 is right here. I had to do a little manipulating with my program because it doesn't match up perfectly with it, but mathematically it matches up perfectly. Just a little bit of the program I'm using's fault. So we see how, again, each point translated along that vector matches up perfectly on the position where it was on the original shape. So moving on down to exercise 2. Exercise 2 says the diagram below shows figures and their images. Images is another word for moved or transformed object. Under a translation along H vector I, vector HI. Use the original figures and the translated images to fill in missing labels for points and measures. So vector HI is right here. I'll line up my ruler with it. Vector HI, let's see, it has it at about 75 degrees, we'll call it. And I can see that, let's see, it is 10, 20, 30, 40, 43 dashes long on mine. So let's check out each of these unlabeled objects and see where they came from. I got to keep my ruler in the same position at 75 degrees, and I'm looking for points that are exactly 43 spaces away, or dashes away, moving in a downward direction. So let's slide this across. Let's start with this point here. So that point there, I have it lined up. Well, almost lined up. I gotta slide this down a little. Reline up. There we go. So it's at this dash. I can see here how it goes to dash F prime. And if I count it out, let's see, 10, 20, 30, 40, and then it's 43. My dash is a little, there we go, move it up a little. There we go. It's at 43. I wasn't lined up perfectly on top. So this right here, this is F prime. We see the apostrophe after it, making this point up here. This must have been the original F. Because again, I see how it was, the vector is in a downward direction. So if this is the original F, I'm guessing that this is the original G. Let's just make sure that matches up. So sure enough, they are lined up at 45 degrees. And there we are, 10, 20, 30, 40, 43. So this was the original G point. All right, so moving on, let's see. I see point A up here. A, line it up a little better. There we go. So I kept the angle the same. If I go down 10, 20, 30, 40, 41, 42, and 43. So this was A prime up here. This, or no, I'm sorry, this is original A. This must be A prime. And you could probably guess what the rest is. Like right here, if I put this on B, I see it lines up down here, 43 dashes away. This must be B prime. C prime. C prime, same deal. There we go. There's the original C. 43 dashes away makes this C prime. Okay. Another thing we should mark up. So since all the points were in the same position, on this one I see how this was a 31-degree angle measure. When we translate it, the angle measure stays the same. So I can say that's also 31 degrees. All right, one more object. Right here, we have E. E, if I line that up, let's look again. 10, 20, 30, 40, 41, 42, 43 dashes away at 75 degrees means this point right here must be E prime. They gave me D prime right here. If I go backwards, 10, 20, 30, 40, 41, 42, 43 means this must have been the original D. Another thing I realized is that again, these stayed in the same position relative to their original. So they are the same distance apart also. So when you translate, the distance stays the same and angle measures stay the same.